Hello everyone, I'm Maria from IPAC Solutions and we're Cadence's channel partner in the MENA region. In this series, we're going to design a 24 GHz microstrip bandpass filter using AWR Microwave Office, and we're going to walk through the complete workflow starting from circuit design all the way to electromagnetic simulation using AXIEM. The goal here isn't just to build a filter, but to understand how the layout, the materials, and the electromagnetic effects will influence the real-world performance of our filter. We'll also compare three key results: the closed-form electrical simulation, which is the electrical circuit that we're going to connect, the measured data, which we're going to import as a NES parameter file, and the full-wave electromagnetic simulation, where we're gonna take our closed-form electrical circuit and extract it using AXIEM and then do the electromagnetic simulation. In this first video, we'll focus on connecting the electrical design and manually defining the substrate. Now, I'm gonna start by defining the units for our project. I'm gonna go to Project Options, Global Units, and then Edit Units. I'm gonna specify the frequency to gigahertz, the capacitance to picofarad, and the inductance I'm gonna keep it as is. This will ensure consistency across the entire design, especially when working at microwave frequencies. Now the next thing I want to do, I want to define the frequency range. I'm gonna go to the My Frequency tab over here, and then I'm gonna replace the frequency sweep with a start of 16 GHz, a stop of 30 GHz, and a step size of 0.05 GHz. This range will comfortably capture our filter response, which is centered around 23 GHz with a bandwidth from roughly 22 to around 24 GHz. Now I'm gonna start by creating a new electrical design. I'm gonna go to the circuit schematics over here, right click, add new schematic. I'm gonna give it the name filter closed form, since I'm going to use closed form components for my schematic. And in AWR, a closed form design uses mathematical expression to calculate values like the impedance, the electrical length, and other filter element values. However, these closed-form models don't fully capture real-world effects such as discontinuities and bands, radiation and coupling, and full 3D electromagnetic behavior. That's why in AWR workflows, closed-form designs are often the starting point, followed by tuning, and then layout extraction, and eventually electromagnetic simulation for accuracy. Now, let's start by placing our components. I'm gonna go to the Elements tab. Here I have all of the components that I can place on my schematic, and I want to start by placing microstrips components and specifically microstrip lines. Over here, I want to place my emlyn, which is my microstrip line. And if, for example, I don't know where this component is in my Elements window, I can go to my Search Element icon and search for example, microstrip line. And over here, I have a list of all of the components that fit this description and a path section that show me where is the path for this component, and then I can place it on my schematic. And now I'm gonna continue by placing the rest of my components for my filter. Now, let's start by changing the parameters for our components that are in our schematic. There's two ways to do this. I can either just double click on one of the parameters and change its value, or I can go to my variable browse window, which is over there. This is its icon. And here I have a list of all of the parameters that are in our circuit, and I can change their values directly over here. Now I'm gonna go back to my circuit and I'm gonna start by changing the width. For my microstrip line, I want to specify it as 0.54 millimeter. And then to switch to my length, I can click on the tab key to switch directly, and I'm gonna specify a 2mm value for it. Now, instead of specifying a number for my parameter, I can specify a variable name, for example, and I can use the equation tool to specify a value to this variable. Now I'm going to continue by changing the parameters for the rest of my components in my circuit. Okay, now that we're done, I want to add a text to my schematic to represent the parameters that are over here. I want to specify the name dimensions, for example, and to change its size, I'm gonna right-click, Properties, and then specify its size over here and that I want it in bold. And I can also draw a rectangle around these variables. I can go to Draw, and then Rectangle, and just draw a shape around these parameters to group them together. And now lastly, I'm gonna go to File and save all of the changes that I have made to my design. Now, a microstrip line is not just a wire. Its electrical behavior depends heavily on the physical properties of the material beneath it. That's why we need to add a substrate block to our schematic, and it is found under the substrate section in the Elements tab. It is the M-sub component over here, and then I'm gonna place it on our schematic and change some of its parameters. In AWR, the substrate also links the schematic to the layout. Without it, the layout view cannot correctly represent spacing, grounding, or electromagnetic behavior. And one of the strengths of AWR is how tightly integrated the schematic and layout are. So to go to the layout, I'm going to go over here and click on this button. And over here, I have a 2D view of my layout with all of my elements placed on my component with these red lines showing the connections between my components. So I can move my components around to make sure that everything is placed according to how I connected them in my schematic. However, another thing I can do is I can Control A to select all of my elements, and then I can use the Snap Together tool to snap all of my components together according to how they are connected in my circuit. I can also click on the 3D view to see a 3D view of my filter and use my left click button on my mouse to move around and see the different parts of my filter as well. Now I want to add a small tip for you. You can easily copy schematics, graphs, or layout into Excel, Word, or PowerPoint if you want. You just need to select the window you're interested in, and then for our case, it's the filter close form, and then you can click to edit or to clipboard, and then you can open, for example, Excel. In my case, I'm gonna open Excel, and then I can just click Ctrl V to paste, or in my case, I'm gonna do a right click and then paste my circuit over here. Now in the next video, we'll run the electrical simulation and analyze the S parameters, specifically the S11 and S21 parameters, and start tuning the filter response.